How to repair DTH power supplies. A complete guide. Hello friends! In this video, we will tackle the repair of several DTH direct-to-home set-top box power supplies, also known as DTH assemblies or S. Each of these power supplies has a different fault, and I will teach you how to diagnose and fix them practically. If you watch this video carefully, you will learn the common faults, how to check components, and the repair process in detail. Initial diagnosis and safety. When you receive a faulty power supply or set-top box for repair, the customer might tell you this symptom, for example, not powering on. However, your job is to find the root cause. The first step is to open the unit and perform a physical inspection. Look for any visibly damaged components like burnt resistors, swollen capacitors, or cracked solder joints. In our first unit, we immediately noticed a burnt component, an inductor, and a blown fuse. The most important component to check first is the fuse. How to check: set your multimeter to the continuity buzzer mode. Place the probes on both ends of the fuse. Result: if the multimeter shows no continuity, no beep, the fuse is blown. This is a clear indicator of a problem, usually in the primary section of the circuit. A quick explanation of an SMPS board. It is divided into two main sections, isolated by the transformer. Primary section, the part where the high voltage AC 220 volts enters. This includes the fuse, input inductor, bridge rectifier diodes, and the main switching transistor IC. Secondary section, the low voltage DC output side. A blown fuse almost always points to a short circuit in the primary section. Repairing Unit 1. The case of the blown fuse and burnt inductor. Step 1. The series bulb tester safety first. Before applying power, it's crucial to use a series bulb tester. This is a safety device where a high wattage bulb, for example, 60 watts, is connected in series with the mains input of the power supply. If there's a short circuit in the unit, the bulb will glow brightly, limiting the current and preventing further damage to the circuit. If the unit is okay, the bulb might flash briefly and then dim or go off. When we first connected this unit with a series bulb, the bulb did not glow brightly, indicating no immediate short circuit. However, the power supply wasn't turning on either. Step 2. Checking the fuse. Our physical inspection revealed a blown fuse. We confirmed this with since we didn't have a replacement fuse handy for testing, we temporarily bridged the fuse holder with a thin piece of wire. This is only for testing purposes to see if the circuit power is on. A proper fuse must be installed for a permanent repair. Even after bypassing the fuse and using the series bulb, the supply did not start. Step 3. Identifying and testing the faulty inductor upon closer inspection. We saw a burnt component near the input. It was an inductor coil. On this board, the input inductor is a 4-pin component that is essentially 2 separate coils in one package. It acts as a filter for the incoming power. We tested it with the multimeter on the continuity mode. Test. We checked for continuity between the 2 pins of the first coil and the 2 pins of the second coil. The meter should beep for both coils. There should be no continuity between the 2 separate coils. Result: the first coil was fine, but the second coil showed no continuity. It was an open circuit, burnt. A bad inductor can cause issues, but it usually doesn't cause a short circuit by itself. The fact that it was burnt suggests another component failed first, causing excessive current to flow through it. However, to proceed, we need to restore the connection. Temporary fix for testing. We bridged the open coil with a jumper wire. I strongly advise against this as a permanent fix. Inductors are crucial for filtering and smoothing the current. Replacing it with a proper inductor or salvaging one from a donor board is always the better option. For now, we did this to get the circuit working for further testing. Step 4. Testing with the series bulb again. After bridging the inductor, we powered the unit on again with the series bulb. This time, the bulb glowed brightly, indicating a dead short in the primary section. The jumper wire had completed the circuit, and now the real fault was exposed. Step 5. Finding the short circuit. The most common culprits for a short circuit in the primary section are bridge rectifier diodes. These convert AC to DC. The main switching, MOSFET, transistor, the primary side capacitor. We started by testing the bridge rectifier. Diodes should only allow currents to flow in one direction. Test. In diode mode, You place the probes on the diode. You should get a reading around 500 to 600 in one direction and no reading OL in the reverse direction. Result: when testing the diodes on the board, one of them showed a short circuit, beeping, or showing a reading in both directions. To confirm, we lifted one leg of the suspect diode from the circuit to isolate it. When tested out of the circuit, the DOD was indeed shorted. A second diode from the bridge also appeared shorted. Step 6. Replacing the faulty diode. We desoldered and removed the two shorted diodes. We then took two new identical diodes. Installation tip: pay close attention to the polarity. Diodes have a silver band on one end, the cathode, which must be aligned with the marking on the PCB. We soldered the new diodes in place. Step 7. Final check and testing after replacing the diode. It's a good practice to quickly check the other components, like the main capacitor and the switching transistor, for any shorts. In this case, they were fine. Now, the moment of truth. We removed the jumper wire from the inductor, remember. This still needs to be replaced and connected to the supply to the series bulb tester. Result: the bulb did not glow brightly. It stayed dim, and we could hear the characteristic faint, high-frequency whine of a switching power supply starting up. This indicated the primary section was now working. We then checked the DC output voltages on the secondary side connector. We got stable readings 53 volts, 24 volts, 12 volts, and 3.3 volts. The power supply was functional again. Final note: to confirm, we connected this repaired power supply to a working set-top box. The box powered on perfectly. Remember to replace that burnt inductor with a proper one for a professional and durable repair. The inductor helps filter out electrical noise, which is important for the stable operation of the set-top box. This first repair covered the most common SMPS failure: a blown fuse, a shorted bridge rectifier diode, and often a damaged inductor. The process of systematic checking from the input side is the key to finding the fault. In the next part of the video, we will move on to the next power supply and see what new faults we can find and fix.